All right, geometry part 2, factoring, and now this is the difference of two squares. So what I just said in the last video was if there was no middle term, right, on your trinomial, then you can make it a trinomial by saying that there were 0 x's in the middle, minus 25. All right, so I have an x squared, I have a minus 25, but I had no x's in the middle, so I represented that with 0 x's. The way that I factor a trinomial, right, a 3-part polynomial, is I want the numbers that add to the middle and multiply to the end, am, like in the morning. And I said that the only way that we could make a 0 is if we had the exact two numbers, but they were opposite. One needed to be positive and one needed to be negative. This is where the perfect square comes in. As far as 25, I know that 25 is the product of two of the same numbers, and that's 5 and 5, right? So if I factored it, I could have an x plus 5 and an x minus 5. 5 times negative 5 would multiply to negative 25, but 5 plus negative 5 would be like subtracting, and that would give me 0. So this is my factored form. All right, the factored form is just the same exact problem, it's just broken apart. Oh, by the way, if I multiplied this back, I would see that I would come back with where I started. X times x is the x squared, x times negative 5 is negative 5x, 5x, well, 5 times x is 5x, and then the 5 times the negative 5 is negative 25. So you see I have the x squared, the middles will cancel, and I would just have the x squared minus 25. It's the exact same thing I started with, it's just in a different form. All of the factored problems work like that. All right, so in the same instance, if I have an x squared and a 36, x squared is x times x, 36 is 6 times 6. So this could be an x plus 6 times an x minus 6. And that is the factored form. And again, like I said on the last video, it doesn't matter which you have first. If you wanted the x minus 6 first and then the x plus 6, that is fine as well. X squared minus 81. 81 is a perfect square of 9. So this is an x plus 9 times an x minus 9. Okay, so this is easy, right? Yes, we totally get this, Miss Jones. And then I throw problem number 8 on here. Okay, 48 is not a perfect square, and there's a number in the front. All the problems that we have done so far, the first 7 problems we did not have a number in the front. There was not a leading coefficient greater than 1. There's an imaginary 1, but other than that, there was not a number in the front. So what do? All right, whenever this happens, I want to see if there's anything amongst them that I can take out. Like, do they have a number in common? And I want to factor that out. So 3 and 48. The biggest number that goes into both of those, its greatest common factor, is the number 3. So whatever I decide to pull out, I'm going to put outside in front of the parentheses. Then I'll divide each piece by whatever number it was they had in common, whatever I pulled out. That will still leave me with the x squared, and 48 divided by 3 will be 16. I keep the sign. It was a negative, so it stays negative. Now, if I look in here, x squared minus 16, that is a perfect square. It is the difference of two squares. All of these have been the difference, meaning subtraction, the difference of two perfect squares. We cannot do it if it is addition. It doesn't work with addition, only with the difference, because I would need a positive and negative to make the 0 in the middle. So that is why it didn't work with problem number 4 on the last one. We need a difference. But back to this, x squared minus 16. I know x squared is x times x, and 16 is 4 times 4. So this becomes an x plus 4 and an x minus 4. And that 3 in the front is still there. It doesn't just disappear. It is still there. Like I said, when I multiply everything back, it needs to go back to what it originally was. I'm not changing this problem. I'm just writing it in a different form. All right, that's part 2. One more to go.